When I talk to people who are just getting started in electronics, a lot of times they're confused about the difference between voltage and current. So I thought I'd do a quick video today to show you what voltage is and what current is and extreme examples of both, so you can visualize in your mind when you're doing electronics problems which variable you're dealing with. So let's start with voltage. Voltage is known as electromotive force. It is the pressure behind flowing electrons. You measure voltage with a voltmeter. Voltmeter, if we use the analogy of fluids or hydraulics or pneumatics, is the same as pressure. So we would measure pressure with a pressure gauge. And if you think about this, pressure gauges do not have any flow through them. Typically, when you put them on a tire, you get a very, very small amount of flow into the meter, back out, and you can make a measurement. That's true with a voltmeter. Voltmeters typically have 10 million ohms of resistance so that they can limit the current of the voltage they're actually measuring. The other variable is current. Current is the same as flow. In fluids, it might be gallons per minute. In a carburetor, it's cubic feet per minute. In a window fan, it might be cubic feet or cubic yards per minute. Flow meter would be something like this. This is a flow meter. It doesn't measure pressure at all. This is a meter. If you live in the city, you have one of these in your basements. It's to measure the amount of flow from municipal water supply. It tells you acre feet of water or cubic feet of water. It doesn't know whether the water's at 60 pounds of pressure or 20 pounds of pressure or 80 pounds of. All it knows is how many gallons went through it, or acre feet, or whatever it's calibrated in. So these are flow devices: flow of electrons, flow of water. And these are pressure devices: pressure of electrons and pressure of air, or similar on a water pump, pressure of water. You can have high pressure at low flow. You can have high flow at very low pressures. You have to have some pressure to create flow. But even low pressure sources can have volumes of electrons, just like low pressure water sources can have volumes of water. This device here, so this is a high voltage power supply. There is a lot of voltage there. To get electricity to arc through air, it takes about 10,000 volts per centimeter. That's at least 10 or 15,000 volts. That's like spark plug wires and stuff like that. Typically, these high voltage power supplies have huge voltages and very little current, milliamps of current or thousandths of an amp of current. So we have voltage, we have current. If you have a meter that looks like this can switch from a voltmeter to an amp meter by changing the range, and it does both. What you have to remember when you're using a voltmeter like this is when you have it on volts, it's a very high resistance between the leads. Just like when you measure pressure, you don't have much flow through a voltmeter, you don't have much flow through a pressure meter. When you switch this over to an amp meter, now it's like this. It's measuring the flow of current flowing through it. Ideally, if you have one of these in your house, if you have 60 pounds of pressure coming in, you still have 60 pounds of pressure coming out. These do not affect the pressure at all. They're just measuring the flow. Same thing with an amp meter. If you put the amp meter in series with a 12 volt battery, you're going to have 12 volts coming in and 11.99 coming out. And it's going to measure the flow to whatever you hook it up. Think of this as an example. What would happen if I took this flow meter and I hooked it up between the water supply and the drain or the septic field and just turned it on? All the water would just rush through this and you'd be measuring how much water you were throwing away. That's what happens to everybody who starts out with an amp meter and says, I'm going to see how many amps are here and then hook this across the battery, because you've just created a very low resistance. It's going to allow all the current that can flow, and if you put this across the battery or across the power supply, it's going to blow fuses, or it's going to wreck this foil on the circuit board, and it's going to burn something up. Hopefully not destroy everything, but it can. Whenever we teach how to measure current in an educational setting, we always have to buy boxes and boxes of extra fuses, because people don't realize when you're measuring current, you have to have the rest of the load in series with the meter. Just like if you had a flow meter You'd want to have the rest of the house, the showers and the sinks and the toilets on the outside of this, and it only draws water when somebody turns something on. Same thing here. If you're going to measure current, you're only going to get a reading, regardless of the voltage, you're only going to reading when the current flows through a load, a light bulb or whatever it is you're turning on. If you hook this directly to ground, it's going to measure infinity and it's going to burn something up. So that's a quick little demo of voltage versus current. And I've got some quick videos I'm going to show you to give some other examples of that. If you have any questions, let us know. I want to give you another example of voltage versus current or pressure versus volume. So in this example, I'm going to use the window fan as an example of volume of air. These things blow bushel baskets of air in a fairly short period of time. This would be a high volume or a high current source. Let's see how long it takes to fill up a garbage bag with air with this. Well, okay, done. 1 second. All right. So there's a lot of volume of air. When you want that air to go somewhere, you need pretty good ductwork. Just like when you need a lot of current, you need pretty big wire. Let's use this same example with the high pressure hose. There's 120 pounds of pressure here, and I am coming through a 1/2-inch hose inside diameter, and I'm going to try and fill up this garbage bag. As you can see, the volume isn't there. This is a device used for high pressure, filling up car tires, that kind of stuff. It's a bad idea if you want to move volumes of air to use this. And it's a bad idea to try and get a lot of pressure out of a window fan. They're different devices for different purposes. Just like a high voltage power supply doesn't necessarily put out a lot of current, and a high current power supply doesn't necessarily put out a lot of voltage. If you think about water pressure, getting its pressure from how high the water is falling, this is known as the flat river. This is an example of very low pressure. But look at the volume that's going on here. This is an example of a very low pressure, very high volume flow. Typical river. How long do you think it would take this river to fill up a 65-gallon garbage bag? 1/100th of a second? This is an example of a low voltage, high current source. This car battery is only 12 volts, and yet it can put out 550 amps of current. That's similar to the flat river. High volume, low pressure. So why all this talk about voltage and current? Well, when you want to get work done, when you want to spin motors, when you want to light lights, you have to have a combination of voltage and current. When you multiply voltage and current together, that gives you wattage. Wattage is a measure of heat, usually as power, but it's also a measure of horsepower, can be converted to wattage and other things like that. If you're trying to determine how strong, how powerful a motor is, or how bright a light is, we use wattage. This is a 60-watt bulb in this setting right here, and it's hooked up to a kilowatt, which is a commercial device used to measure voltage and current. And right now, it's showing 122 volts and 0 amps. If I turn the light on, you can see that the current goes to 0.47. So that's the current that is flowing through the light bulb when I turn it on. 0.47 times 122 volts is 57.34 watts. This is a 60-watt bulb. It's putting out 57. So that's pretty good. This will also just tell you watts. So I just hit the watt button and it says 55.6. So we got a little rounding error here, but pretty close to a 50-watt bulb. Now, let's look at the headlight bulb of a car. What I have here is a battery charger. And instead of using the electronic meter that does all of this voltage and current, I'm going to do it with independent equipment. So what I have is the battery charger, which is 12-volt battery charger, and I'm going to plug that in so that I can measure the power coming out of the charger. Right now, I have a voltmeter hooked up to the battery charger, and you can see right here that the voltmeter is on the 15 volt range, and it's about 11.5 volts. And like you're supposed to, the voltmeter is hooked up in parallel with the output connectors of the power supply. That's how voltmeters are hooked up. In order to measure current, as we talked about earlier, we have to go through the wattmeter and then through the load. So I'm going to tap off right where the voltmeter is, which is the same terminals as, hooked to the same terminals as the battery charger. And I'm going to go into the ammeter first. So this ammeter has a common positive. And then I'm going to come out of the ammeter, and I'm guessing, let's guess at 5 amps. I think it'll be in that ballpark. And we're going to go into this light bulb right here. And this is a headlight designed to run on 12 volts. And then we're going to come out of the light bulb and go back to the negative side of the power supply, which is right here. Light bulb is on. Ammeter now reads on the 5 amp scale. Where is 5 amps? 543, about 2.5 amps. Now this bulb has a bright and a dim, so I'm going to go to the other filament. I'm not sure which is which, and I'm still at 2.5. So 2.5 times, this has dropped down a little bit. It's about 11 now because under load it dropped down. So 2.5 times 11 is 2.2 amps times 11 volts is 24 watts. That's each one of these filaments one at a time. This is about a 25 watt bulb. It's a headlight, and depending bright or dim, they just change the focal point. If I hook to both of these simultaneously, which sometimes I can get the alligator clip to do, I now have both filaments hooked up simultaneously. I'm pulling almost 5 amps of current, 4.5 amps, but my voltage has dropped down to about 10. So I'm getting about 40 watts now, power coming out of the power supply. The power supply is plugged in to the kilowatt, and it's showing 77, but that's because the transformer and the diodes in the battery charger are not 100% efficient. The output power into the light bulb is about 45 watts with both filaments driven. You're not supposed to do that, but simultaneously, but it can do one or the other. So to measure voltage, you put the voltmeter in parallel with the power supply. To measure current, you always have to come out of the power supply, go into the wattmeter or into the amp meter, come out of the amp meter, go through the load, and then back to the power supply. If you ever hook the amp meter up without the load, it's gonna be a complete short because the amp meter has almost 0 ohms of resistance, and it's gonna either blow a fuse in the power supply or the amp meter or both. Here we have an example of high voltage and high current. If you look at the length of these insulators on these high tension power lines, they're probably 6 or 8 feet long. Going through these high tension power lines, hundreds of thousands of volts, and I don't know exactly, probably depends on the time of day, probably hundreds of amps. This is an example of real power. There's a freight train of energy coming down these lines when they're pushed hard on a hot summer day with air conditioners running and stuff like that.